Welcome everybody to the Electric Education Center session 7 of the educational series. Today's subject is electric vehicle car chargers. First of all, let's get something straight here. Electric vehicles are here to stay, and I'm not referring to hybrids. The all-electric vehicles in the United States number about 2 million today. The hybrids were like a stepping stone, like a stopgap method of introducing the all-electric vehicle. But the hybrid car, which runs on electric, and then when the battery is down, it switches over to gasoline. Why put two different technologies in one vehicle? I don't get it. But anyway, the industry doesn't get it either. And the sales of the hybrid electric vehicles peaked in 2013. Now that the industry has proven itself and the people trust the product, the trend is towards all electric vehicles. For example, Chevy was selling the Volt hybrid, but it's being phased out now because the Chevy Bolt, think Lightning Bolt, is outselling it. The car you want today, a nice, pretty Nissan Leaf, or a stunning Tesla, or a very practical Chevy Bolt that can go around 240 miles on a single charge, that's what you want. There are others coming down the pike also. No pun intended there. Subaru is going to have a model soon. Volkswagen, Mercedes-Benz, Audi, Ford Mustang, Volvo, BMW. Work vehicles are available also. Electric pickup trucks are also coming this year. A Tesla Cyber truck 500-mile range. An electric Ford F-150 production is due in 2022. Chevy Ultium pickup truck with 450 miles. So GM's Hummer is back with an electric model with a 350-mile range. Rivian is the new American company that makes a vehicle that can get either 200, 300, or 400 miles, depending on what battery pack you want to buy. They have a contract to build 100,000 delivery vehicles for Amazon. If you want to read an amazing article, just Google Rivian, R-I-V as in Victor, I-A-N, to get more information. Well, let's cut to the chase. Electric vehicles are here to stay. Simple as that. More are sold every year. Electric buses, pickup trucks, work vans, motorcycles, and other vehicles are available. Yeah, Rich, but it takes energy to make the batteries, man. I know that. But on the flip side, it's better if there's only one burning fossil fuel, and that would be the electric company. It's far more efficient and less polluting if the electric cars are charged individually and only the utility is the one who burns the fossil fuel, rather than having every car going around burning fossil fuel like we do now to get where they're going. In Europe, the following European countries have banned the ICE, that's the internal combustion engine, and the list is growing. Norway was first. Germany, India, France, United Kingdom, Denmark, Netherlands, Ireland, Costa Rica, and Belgium. Now, most of these bans are for 2025 and 2030. Some are set for 2040. Costa Rica is this year. They are banning the internal combustion engine. You're only allowed to run electrics. What's California doing? The country of California gives up to $9,500 rebate towards electric vehicles and hybrids. The goal is zero carbon emission electric vehicles, and 5 million of them are the current goal by the year 2030 in California. At the end of 2019, there was more than 600,000 zero emission vehicles in the state of California. That is an all electric, it's not a hybrid. By the end of 2020, there were more than 835,000 zero-emission vehicles in California. The number of public charging stations is staggering. 1 to 10 charging locations used per vehicle in normal travel routes is the norm. Do the math here. 835,000 electric vehicles in California. That equals 835,000 home charging stations. Charging stations, 240 volt, cost between $300 and $700, for example. Add to that the cost of the wire or conduit and wire, and a 2-pole circuit breaker. How much labor to charge per install? $800, $1,000, $1,200. I don't know what your company is going to charge. But let's just look at this. 835,000 electric vehicles at only $1,000 labor per charger. That gives $835 million. That's just the labor, and that's just the state of California. What's the state of Connecticut doing? The state has 12,000 electric vehicles now. Their goal is to have 500,000 electric vehicles by the year 2030, 9 years from now. That equates to another $500 million of labor only. Is your company ready? Electric vehicles are here to stay, like I said. The numbers are going to increase every year. Is your company going to be ready to promote the industry? Is your company ready with the ability to design a charging system? Is your company ready to install these systems? Is your company ready to pass inspection the first time? How many electric vehicles does your company own right now? Well, we don't have any. Well, why not? What are you waiting for? Well, lease something. Do something. All right, let's take a look at some slides here. All right, here we go with, this is my 2016 Nissan Leaf. Pretty little car. I bought this when it was 2 years old. I bought it used off of a car lot. And at the time it was $16,000. You could put that on a credit card. And then the state of Pennsylvania gave me $1,000 rebate. So that brought it down to a $15,000 car. I drive this every day. I drive this everywhere. And you can see my Ford Explorer in the background there. That thing, that gas guzzler, does a lot of sitting these days. So here's some of your electric passenger vehicles. You know, you got your pretty looking Tesla, and Tesla has some affordable models also, not just the real expensive ones. They have affordable models in the $35,000 range, and then you get $9,000 or so rebate money back from the state, depending on your state. Here's electric buses, SEPTA, Southeast Pennsylvania Transportation Authority, and they run the electric buses, and boy, are these pretty looking vehicles. They raise up and down to allow the passengers to get on and off easily. They have a fleet of 25 of them, and for a while they ran that green one there as a sample and just for demonstrations. They ran that for a while, but they run these 25 electric buses every day. Electric trucks, you got a nice Tesla looking pickup truck there. You have Chevy coming out with a model. And for all you guys that are working, all your electrical contractors, there are work vans available. On the bottom right down there, you can see Amazon Prime. They are going to be using those vehicles there. I'll be talking a little bit more about that in a second. The Philadelphia Car Show last year, here's your Chevy Bolt. You know, think of a lightning bolt. The Chevy Volt, V-O-L-T, is being phased out. But this lightning bolt, the all-electric, is the one that's selling. It's not a hybrid. I mean, that's a pretty looking car there. So let's get back to the subject of today. Electric vehicle car chargers, make sure you're using the correct issue, as it says, of the National Electrical Code. Up into the 2017 NEC, the title of Article 625 is Electric Vehicle Charging Systems. Now, the 2020, with so many changes regarding these chargers, for example, over current protection, power transfer, not only from the dwelling unit to the vehicle, but also from the vehicle to the dwelling unit. It can backfeed the house if need be. GFI protection only for 240-volt receptacles and not outlets. that are directly wired to the charger, unless the manufacturer requires GFI protection, and also GFI protection for any onboard 120-volt receptacles, and there's several definition changes. So the 2020 has some big changes, and now they changed the title of it to Electric Vehicle Power Transfer System. So on the job, when you want to install a car charger for somebody, what's the AHJ checking? What's your electrical inspector or the building inspector checking for? Well, first of all, they want a job permit. You don't want to do any work without a permit being pulled. The inspector will want a copy of the manufacturer's instructions and the installation manual. You may have to download that and print it out yourself and give them a copy. The height of the equipment above the walking surface he'll be looking at, the distance from the curb line. You know, give me some clearance so I can open my car door. He'll be looking for trip hazards, overcurrent protected devices, conductor sizing and wiring methods, and anything else that's particular to your job site. He's also going to look for physical protection for the charging station, either by way of bollards or parking blocks or raised concrete platforms. GFI protection of all car charger receptacles. Note the GFCI protection is not yet called for if the charging station is direct wired. Like I said, unless the manufacturer calls for it. The present design of these charging stations ensures that the station will trip a GFCI type device because of an imbalance between the two hot conductors, such as what would be caused by wet or damp situation on the vehicle with the wiring. And this is referred to as personnel protection system in section 625.22 of the NEC. Blink charging stations here at any IKEA store you go to, you can pull up to a Blink charging station. I recommend that you get the Blink credit card because the regular cards that you could use, like Visa or MasterCard, you could use them, but it's going to be a slightly higher fee. So pick up yourself a Blink charge card. All these IKEA stations are level 1, and maybe about half of them also offer level 2 charging, which I'll talk about in a second. Here's one on Columbus Boulevard in Philadelphia, and you can see the bollards there that will give this charging station a level of mechanical protection, so the car bumpers don't bump into it. And just like the free filling stations for air at the gas stations, put this cord back on the hanger where it came from. Don't be throwing it on the ground like that. So the AC versus the DC charging equipment. Presently, a level 1 charger supplies AC to the electric vehicle, and then the vehicle charger converts the AC to DC. Level 1 is also known as a trickle charge. It's a slow, low-level charge. A level 2 charger supplies higher level of AC at 240 volts and charges it at a much quicker pace. Level 3 charger or supercharger already converts the AC from the utility to DC. And they do that in the charging station, and that delivers pure DC to the battery for super fast charging times. So that's all you have is level 1, 2, and 3. The most common charger plug you have is the J1772, and this J plug is used for both level 1 and level 2 charging voltages. That would be 120 volts, 240 volts, respectively. Do them both with the same plug configuration. So when you buy your new electric vehicle, you're going to get a cord similar to this. All it plugs into, you can see there, it plugs into any 125 volt, 15 or 20 amp receptacle, and then the cord has to reach your vehicle. So no matter what house you're at, what building you're at, wherever you're at, you'll be able to plug into a normal receptacle, an everyday receptacle, to get some charging for your car. This is a level 2. And these can be configured or set for 30, 40, or 50 amp circuits. This is a 240 volt, gives you a much quicker charge. All right, so your level 1, 2, and 3, you can see down there on the bottom left, the level 1 is going to give you 5 miles per hour of charging. Level 2 is going to give you 10, 20 miles per hour or more. Level 3 is the supercharged. That'll give you 80% full charge in 20 to 30 minutes, anywhere from 480 volts to 800 volts DC. You know, when you're going down the Route 95 from Maine down to Disney World, you're going to see these charging stations like at the Maryland House. At the Maryland House, they have like 10 charging stations for normal people, and then they have another 10 charging stations for the Tesla people. All right, so in the time it takes you to go in and get your quarter pounder with cheese and finish a little meal like that, by the time you come back out, you got a full charge. You're ready to go again. All right, so these are the configurations of the receptacles. Level 1 is going to use the J1772. Level 2 is also the J1772. DC fast charging, it can be this combo, or it can be CHAdeMO type configuration, and Tesla will give you a combo to, again, handle any voltage available that you can pull up to. So don't be worried about, oh, will I be able to charge my car? Yes, you'll be able to charge your car anywhere you want. Don't worry about it. So the Chevy Bolt, here's the Chevy Bolt inlet, and it'll accept all 3 levels of charging, as do most of the rest of the EVs. Here's your Nissan Leaf, J plug and supercharge. Over on the right-hand side there, you have the J plug for the level 1 and 2. All right, this one on the right, 120 or 240. Over here on the left, underneath this cap, you have your DC fast charging level 3 supercharger inlet. So if I was driving my Leaf down to 95 and stop at the Maryland House, I would be opening this cap and plugging it in and getting a quick charge. The cable set, the max cable length for these chargers here, this is AeroVironment model here, the green one. Max cable length limitation used to be 25 feet in the 2017 NEC, but it was deleted. That rule was deleted for the 2020 because the manufacturers say, why are you limiting us to 25 feet? We may have a longer cord. So the NEC code making panel got out of the business of saying how long or what was the limit of these cords. All you got to do is make sure that the charging equipment you install is listed and labeled. That means like with a UL label, for example. NEC Article 625, Electric Vehicle Charging System. The scope is electric conductors and charging equipment external to the electric vehicle. Now, the charging equipment can be conductive, using a cable set or a cord, or the charging equipment can be inductive, meaning wireless transfer of power, just like transformer operation. The WPT in the National Electrical Code, transfer of electric energy from the power source to an electrical load by way of a magnetic field and electrical induction. It's the same type of action you get in the transformer between the primary and secondary coils. There's no physical connection. It's all an electrical magnetic field connection. So check out Article 625, Section 625.101 for grounding and 625.102 for installation guidelines of these wireless power transfers. The primary pad for the wireless charging is a piece of equipment, like I said, external to the vehicle, and here's a picture of it. And this can be installed in roads, in parking areas, on streets, parking garages. They can serve cars and buses, etc. And this style will work anywhere where installing a pedestal type will not. So, you know, any city you have, Boston, Philly, Atlanta, Peoria, San Francisco, you know, any place where you have like row homes in the city, you can't have a bunch of electric cords strung across the sidewalk. All right. Hopefully you could install something on the front of the row home and then just the cord comes across when you're charging. But even then, you know, these cords are going to be tripping hazards. People are going to be driving over them with their vehicles or their wheelchairs or their bikes or whatever, pulling wagons and all that. So we can't have that. We're going to have to go to this in-ground type of charging system. So here's a typical residential wall charger. It's not direct wired. You can see that it's plugged into a receptacle, but the code limits it to a 12-inch cord to supply the charger. But again, that's deleted in the 2020. But I don't know if the manufacturers are going to change that rule that they put in a 12-inch cord and that's it. So the 2020 NEC just says, hey, follow the product standard. That means follow the manufacturer's instructions. Now you got to be sure of the installation location for rough wiring, okay? Because this wall charging unit here has to be at a certain height, and you don't want it to be below the bumper level. And that means that you're only getting a 12-inch cord with this unit. That means you got to know where you're roughing in this box. Don't just throw this box and rough it in anywhere you like and say, I'll take care of it later. No, you won't. You got to think ahead on this because you are limited to a 12-inch cord out of that unit. So if you're going to plug it in, that's one thing. If you're going to direct wire it, that's another thing. Your charger cable interlock, the electric vehicle charging equipment has to have an interlock that will de-energize the EV connecting cord whenever the connector is uncoupled from the vehicle. So as soon as you unplug the cord that I showed you earlier from the vehicle, that has to be de-energized by the charging unit itself. This is a manufacturer requirement, but this rule is going to make it not easy for an electrician to try and build their own system. There's a couple of exceptions to 625.18, which may be moot since that section is deleted from the 2020 NEC. So you'll see 625.18 in the 2014 and 2017, but it's removed from the 2020 NEC. So that output cable from the charging equipment to the vehicle shall be type EV, EVJ, etc., and that has to be a flexible cable as specified in NEC table 400.4. And then it shall not exceed 25 foot in length unless it's equipped with a cable management system that's part of the listed EV supply equipment. Read the manufacturer's instructions. So the supply cable length limitation of 12 inches is on the supply to the charging station. Now, if you're going to put a receptacle, that receptacle can be installed indoor or it could be installed outdoor with proper extra duty enclosure, an in-use cover. But if you use receptacle, it's going to have to be GFI protected. So in the 2020 NEC, your new requirement is 625.54. That section requires GFI protection for all charger receptacles, no matter the voltage and no matter the location. Inside the garage or outdoor on a wall does not matter. Now, one problem is the current design of some of these charging stations will trip a GFCI class device. That's one that's designed to trip at 5 milliamps plus or minus 1. Whether it's a receptacle or a circuit breaker, the charger will trip it. So then your only option with that particular model is to remove that 12-inch cord and direct wire the unit. The personnel protection system, the EV charging equipment has to have a listed system of protection against shock for personnel per NEC section 625.22. Well, what does that mean? I don't know, because there's no definition of personnel protection in the National Electrical Code. So I did some research on it, and this is some GFI imbalance type protection that is built into the charger. And this rule is directed at the manufacturer, not the installer. And the reason for that is because if the vehicle has a moisture problem or something like that, It has to be able to trip and protect itself, protect the people really, and then reset itself automatically. So that's what that personnel protection is all about. Charging station installation, important talking points in my 4-hour class. I would do a Zoom 4-hour class if anybody wants to have that kind of training. Just contact me, richvanwert@gmail.com or rich@electriceducationcenter.com. But what we go over is branch circuits, overcurrent protection, the ratings of the units, the voltage drop, how to install a disconnect and where. Equipment connection, is the equipment portable? Is it stationary? Is it fixed? These are all items that are defined in Article 625. How do you handle loss of utility power? How do you handle interactive systems like solar? Where's the location for these charging units? What are the rules there? How do you handle ventilation? How do you handle GFI protection? What about permits and inspections? So there's a lot to cover here. And if you, like I said, if you want to schedule that class, just contact me. So the branch circuit required in NEC 625.40, it's generally allowed to use any existing 125 volt receptacle and branch circuit to power a charger for a trickle charge. But if you install a new individual branch circuit, what you guys call a dedicated circuit, the code calls it an individual branch circuit, and if you're going to put one in for a charger, that circuit shall have no other outlets. End of story. That applies whether it's 125 volt or 250 volt. The charging action on these chargers shall be considered as continuous duty, meaning 3 hours or more of continuous use. So you have to follow some rules in the NEC for continuous use and how much you can load up a receptacle or a breaker or a circuit, and always follow the manufacturer's rules. The GFI protection required by the 2020 NEC, in addition to what you find in 210.8 for a dwelling unit, all receptacles installed for the connection of electric vehicle charging equipment required to provide GFI protection for personnel, no matter where that receptacle outlet is located. And that's information is in the 2020 NEC section 625.54. However, direct wired vehicle chargers do not have to be GFCI protected unless the manufacturer requires it. 625.60, AC receptacle outlets used for electric vehicle. There's a new section requiring all onboard receptacle outlets on or in an electric vehicle to be installed in a readily accessible location. Not too hard to do, since it's right on the vehicle. There's a common occurrence to see 120 volt AC receptacle outlets on board in vehicles, not just electric vehicles, but even gasoline engines. Somebody's pickup trucks, you know, have receptacles on them. But these onboard AC receptacles will be required to be listed and rated at 250 volts maximum, single phase, and 50 amps maximum, with overcurrent protection integral to the power export system. Should a person be less protected in their electric vehicle when they're away from home than they would be in their own garage? Not really. So that's why the code is requiring that GFCI protection. Your equipment rating in the first place shall have a rating sufficient to serve whatever load you're connecting to it. And you can't add additional loads that this charger was not originally designed for, or the circuit was originally designed for. Contractors should not, and inspectors should not allow people trying to connect additional charger receptacles on an individual branch circuit originally installed for one vehicle. The individual branch circuit is only allowed to serve one outlet. A second outlet, you run a second branch circuit. Commercial disconnecting means in the NEC section 625.43 for charging equipment rated over 60 amps or equipment rated over 150 volts to ground. So over 150 volts to ground translation is your 277 480 circuits. The disconnect shall be provided and installed in a readily accessible location, meaning you could walk right up to it. The disconnect has to be able to be locked in the open position. Now, the NEC does not yet require this disconnect to be within sight of the charging equipment itself. Inside of or within sight means you can naturally see it, and it can't be any more than 50 feet away, but the code does not require that within sight rule yet. So here's a piece of equipment, a Proterra Charger, and it's rated over 60 amps. Voltage is higher than 150. So you have to have your disconnect. You can see it there. It's marked with a number 3 on the unit. And it has to be able to be locked in the open position. But like I said, that disconnect doesn't have to be within sight. That particular one is. It's okay. Your wireless power transfer equipment, the code calls it WPTE, has rules for grounding, what type of enclosure is allowed, installation location, primary pad information, and protection of the output cable. So here's a wireless charger, and this is NEC Code Article 625, Part 4, Roman numeral Part 4. The EV charging equipment shall be located for direct electrical coupling of the vehicle. Translation, no extension cords or homemade cords. Now, I'm off of the wireless. I'm talking about the ones that you do connect with a cord now. So unless listed or marked otherwise, the coupling means the cord shall be stored or located at a minimum height of 18 inches indoors and 24 inches outdoors. This rule does not apply to portable charging equipment. So your minimum cord height is 24 inches for this outdoor installation. And you can see that this cord is 24 inches up above the ground level. Here's a violation here because the cord is not being stored above the 24 inches. So whatever you install, you have to give the customer the ability, at least, to store that cord above 24 inches. Manufacturer references, you can check out online. Check out Blink. There's no letter I in there. It's just BLNK. ChargePoint is the charger that I have at my house. AeroVironment is the green charger you saw earlier. Tesla, you can Google Tesla. You can Google the Chatamo Association to get information on the plug-in receptacles. Siemens has information, Bosch, Juice Box, and Lev. All right, so there you have it. There's a little bit of information on electric vehicle car charging equipment. What you're going to do on your to-do list. You're going to purchase an electric vehicle today. You're going to purchase a charging system for your work or home or both. Apply for all rebates that your state offers. There's some very, very good rebates. And don't get left behind. That's all I have for today. Van Wert out.